Prove that angle bisector of any angle of a triangle and the perpendicular bisector of the opposite side is not is if intersects. If they do intersect, they will intersect on the circumference of the circle. So let me explain the question before we start discussing about it. So we have a triangle ABC. If I consider say a triangle, not triangle, angle B. To angle B, what is the opposite side? The opposite side would be, yes, AC. Okay, so the question is quite simple. If I have a perpendicular bisector and an angular bisector for this particular angle and this particular side, particularly this, something like this, opposite side and opposite angle, the point wherein they meet, if they do meet, it will be on the circumference of the circle. So this is your question. Okay, so we had to prove that that point of intersection has to be on the circumference of the circle, nowhere else. So we can go with proof by contradiction, or another way is what I'm going to do. So I'm going to take up one condition and prove the other condition to be true. So let me show that and explain. I have triangle ABC. So now to AC, the side opposite to angle B, I'll draw a perpendicular bisector. So let's call this as point D and let's call this as point P. So for ease of working out things, we'll join few things and we'll name anything. No, not required. Now let's describe what we have done. So let's consider a circle with center O circumscribing triangle ABC. Okay. Next thing is, let's consider a perpendicular bisector. So I told you initially that we'll take up one factor and prove the other factor. Let's consider a perpendicular bisector of side CA, right? So first thing is, as it's a perpendicular bisector of a chord, the chord being CA, right? It will pass the point O. Okay, yes, it will be going through this point. Next is, let the perpendicular intersect the, see, this is what I told. I'll take up one of the factors. Intersect the circle at point P. So basically, yeah, we have one more thing before talking about anything else. Let point D be the point of intersection just a second, intersection of CA and PO. Okay, yes. And then we have the next factor. What else? Oh yeah, we need to join quite a few things. We are not explained that. So let's join. So we are joining starting from PC, PB and PA. All of this will join. We already joined two. Let's join the third one, this particular line. So if I prove that these two angles are equal, we are done basically. Okay, so that's what we're going to go towards. So let's do it one step at a time. So we'll start with the proof. So what do we have in triangle? Yeah, I need the diagram actually. Without this, back and forth will be a headache, is it not? in triangle PCD and triangle PDA. Check out where is it. Let me make it a bit simpler for you guys. PDC and PDA. Okay, so we have these two triangles. First one and the second one. So those are your triangles. So in that, what is happening? PD is common. So where is that I'm taking this towards? This conversation will end up showing that those two triangles are, yes, congruent. Correct. Next is angle CDP is equal to angle ADP. Both are equal to 90 degree. But why? Because PD is perpendicular to CA. And at last we have DA. Yeah, DA is equal to DC. And this is because of PD is perpendicular bisector of CA intersecting or bisecting at, yes, D. Yes, we are writing a lot. I know, I understand, but again, this helps. Therefore, triangle PDC is congruent to triangle PDA, right, with SAS congruency. Okay, and then we can tell that angle PCD is equal to angle PAD. Is it not? By CPCT. Okay, so with this we can tell one thing. If I take this as X, this also will be X, right? With this I'll end with the following thing. If this is X and this is X, this too will be X. Why is it so? Because angle PAC, such where is PAC, is equal to angle PBC, and angle PCA is equal to angle PBA. Now the question is why? Think about it. You have the reason on the screen. Yes, angles in the same segment of a circle are equal. Okay, guys. So basically what we have here is this. Say take PA as the base or the chord. If I join all of this, what will I end up with? Kind of a segment. Now, with PA as the base or the chord, if I happen to talk about two angles with the same side of the segment, right, something like this, what happens? What are we looking at? Because this angle, which angle? This angle is X. This angle is X. This angle will also be equal to X. Is it not? Because they are on the same segment of the circle, right? So that's what I have written in one of this, which is this now. PBA is this, which is equal to PCA, right? Agree? Okay, those two are equal. Next, the other part of the segment, not other part, sorry, other part of the writing over here, that we can prove by considering the following. If this is your, why is it not coming? Yeah, now it came. Oh, I'm pressing the wrong button. If this is your segment, what do we have? This would be your chord. What am I telling? If this is your chord, this is your segment, right? And major segment, that is. And if I happen to join the chord with the circumference of the circle at the same side, what do we have? These two pairs of angles will be equal. And so I have written over here the same thing. Okay. And end of it, what do we have? We have the following thing. Angle subtended in the same segment of the circle, are equal. Okay, so from the next thing is from 1, 2 and 3, what can we tell? That we have angle, there's two set of angles to be equal to each other. That's what we wanted, is it not? So from 1, 2 and 3, what do we have? We have angle PBA is equal to angle PBC. Okay guys, and this, from this, what can we infer? We can infer the following. We can conclude the following, and that is key PB is an angular bisector of what angle? Of angle ABC, and thus the statement is proved. Thus the statement is proved. How is this? We have something like this: PB, an angular bisector, meets the perpendicular bisector of side CA. Okay, which is an opposite side of angle B on the circumference. Again, I'm just trying to be safe. I know there's a lot of writing, but again, it's easier to understand, so I approach this way. Okay, so you can pause and have a look at the answer now.